Okay, in this video we're going to talk about Unit 1, Objective 2, which is sketching the graph of a derivative. Now if you remember from before, the derivative is just the slope of the tangent line to a function at any given point. So when we go to graph a derivative, we're going to take that slope's value, the slope of the original function, and that's going to be the y value of our derivative's graph. So we're taking the original slope and that's going to turn into the y value of the graph. Now, one thing that we need to keep in mind is we're no longer working with just linear functions. We're going to have curves. And since we have curves, our slope is always going to be changing. It's not going to be a constant slope the entire time. And that's going to show you, we're going to see that the derivative is going to be its own function because of that. So if we look at a polynomial, and if you're curious about the function, it's right here. It's real goofy. But we get this nice little blue graph here that represents this function f of x. So what we're going to try to do is graph this function's derivative. So we need to figure out what the slope is at every single point on this curve. And then we're going to try to plot that function or that slope as a function of x. So what we can do is push this little button here and we get a random x value. Right now it's at negative 0.197. Right here's negative 1, so we're not really that far over. We have the corresponding value on the function, which we're calling p, and that's going to be 0.464. And then you see this little black line here. This little segment is a segment of the tangent line to that function f. And you can see over here in green, the slope of that little tangent line is 1.073. Now you'll see that this is rounded to 3 decimal places. That's done on purpose. That's how far AP wants us to round, is to 3 decimal places. So if we look right here, I mean, you can see that the segment is a positive slope. If you ignore the function and look just at that little segment, you would say, yeah, that's a positive slope. If we take x and we move it over here, we can see that this segment now has a negative slope. So we can go a little bit farther, and then it's really, really negative, right? Negative 5.68. And then if we go from a spot over here where we have a negative slope to a spot over here where we have a positive slope, well, if we're going from negative numbers to positive numbers, somewhere in between there, we have to hit 0. So if you think about it, right at the bottom, that minimum right there, that's about as close as I'm going to get. Our slope is going to be 0, right? It's not exactly 0 right here, but it's as close as I'm going to be able to get with this little slider. So we are going to know that if we go from a negative slope, right, negative slope over here, to a positive slope over here, somewhere in between them, we're going to have a slope of 0. Now, if we keep going over to the right, we have a positive slope here. We're still positive. We have a positive slope here. But something weird happens right about there. Once again, we have a 0 slope. So just because we went positive and we stayed positive, that doesn't mean we're always going to be a positive slope. We can get down to 0 slope. And again, I can't get exactly where it is. But that's pretty close to being 0. So when we go to graph the derivative of a function, what I like to do first is try to find the spots on this function that we have a slope of 0. So on this one we can see we have a slope of 0 somewhere around here, and we have a slope of 0 somewhere around here. So what I like to do first is I like to section off my function into places where our function's derivative is not 0. So we know we're 0 somewhere around here, so I'm going to put a little vertical line about there. I might move it a little bit over. So I know right there, whatever that x value is, my derivative is 0. The slope of this blue line, this blue function, is 0. And we knew we have another one somewhere around here as well. So our slope somewhere around that x value, whatever it may be, is also 0. Now, the good thing about finding all the places where our slope is 0 is now we know everything in each of these 3 sections over here, and over here, are all going to be the same value, either positive or negative. Now the number is going to change. The slope's not going to be the same everywhere, but it's going to be the same positive or negative. So if we look everywhere from all the way over here up until that black line I put in, we have negative values for the slope. You can see in that little green thing up here, all those values are negative. Then somewhere around here it changes, and if we look, everything's positive. And it gets really, really, really small, right? We're starting to decrease in value for our slope there. We're starting to get a little bit of a horizontal tangent line, right? Horizontal slope right there. And then it starts to get bigger again over there. So when we go to graph this thing's derivative, remember back on this slide here, we said the derivative, the slope of the original function is going to be the y value of the derivative's graph. So we know since the slope all the way over here is negative, all the y values from the beginning of my graph to this line here is going to be negative. Everything in between these two black lines was positive as far as the slope was concerned. So our y values are going to be positive everywhere. And then everything from here to the end was also positive, so our y values are going to be positive. But what we want to remember is on these black lines, these vertical lines that we put in, our slope was 0, so the y value has to be 0. So we'd put a little dot right here, and we would put a little dot right here. Now, we can show that green dot that I just put up there, that represents the y value of this slope. So if we look at the slope's 1.01. Here's 0.5, here's 1, so 1.01. So this green dot represents this value here. So as I slide it over here and over here, right about there, I was pretty close. You can see that f prime, the derivative, crosses the axis. And then if we look over here, it's always down here in the negatives, right? Negative 1.94. Here's negative 2. So there's our y value. We hit that spot where it's 0. Then we go all the way over here. Everything's positive, everything's positive, everything's positive. But right there, our tangent line becomes 0. Our slope becomes 0. So our f prime, that green dot, has to be on the axis. And then we start to move over and it goes up again. So we can show what the derivative actually looks like. And I was pretty close on this one. This one I was a little bit off. We can move that over to be a little bit more accurate. But if you notice, as we trace that green f prime dot goes over the f prime function, our slope, this black segment here, is negative. So all the y values of my function are negative. Moving over, moving over, moving over, moving over. Boom, the slope there is 0. So the green function has to be 0. And moving over, oh, moved the wrong thing. I think I'm going to lose the slider there, so I'm just going to trace it with the mouse. As we go in between these two black lines, my function is always positive. But remember, this black line represents where the slope of the blue one is 0. So my green one has to hit 0, and then we go up to the positive again. So let's look at one more, and then we'll call it quits on this video. So here we have the function sine of e to the negative x divided by 2. So we get this nice little function here. So remember, the first thing we want to think about is where is the slope of this blue line 0? So if we think here, we know it's negative. Here we know it's positive. So that means if I'm going from a negative to a positive, I have to hit 0. So I'm going to put in a vertical line to represent that slope of 0. Apparently it's going to be yellow this time. And it's going to be 0 right at the bottom of that minimum. So we'll say, I'm a little bit to the left, we'll say right about there, it's 0. And then if we're looking at the slope of the blue line, it's positive here. The slope of the blue line is negative here. So we know if we're going from a positive slope to a negative slope, we have to have another 0. So let's put in another 0 for our derivative, and we'll say right around there. our slope is going to change from being positive to being negative. And then let's kind of check the rest of the way. 0, 0, or sorry, negative, 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 negative. And it gets pretty close to 0 right here, so our function might hit the axis. The derivative might hit the axis here, but I don't think it's going to have to. So if we show our segment for our tangent line, we can double check and see, yes, our slope was negative, yes, our slope's positive, so somewhere in there it's got to be 0. Yeah, our slope's positive, our slope's negative, so somewhere in there our slope has to be 0, and then it's negative all the way through, and you can see it doesn't quite get to 0, 0.055. That's not close enough to 0 to go ahead and put it on the axis, so we're not going to say it hit 0 there. If we show the point that's on the function, the point there where our slope is represented by a point, so our slope is negative 1.988 at this x value. So at this x value, our derivative has to be down here at negative 1.988. We can slide it, and if you notice, we're pretty close there, right? Our slope is 0, so our derivative has to be touching the x-axis. So we're going to go up, still a positive slope, but now we have a 0 slope again right at the top of that little bump, that maximum. And then our slope's negative, so it goes, and you can see as we're getting closer to a 0 slope this way, our function's getting closer and closer and closer to the x-axis. But it doesn't quite get there. So we can graph the derivative, and there we go. And you notice everything to the left of this yellow line, as far as the original function, the blue function, is concerned, all of those slopes were negative till we got to there. So all of the y values on the green function, the derivative, had to have been negative. Now, in between these two yellow lines, our slope of the original function, of the blue function, is positive. So our green function has to be above the x-axis the entire time. But as we're getting closer and closer and closer to that top, our derivative is getting smaller and smaller and smaller until it eventually becomes 0. So our derivative, that green function, needs to hit the axis. And then our derivative, our slope, becomes negative. And it gets closer and closer and closer to 0, but it doesn't quite get there. So you can see we don't quite get to 0 on that one. So that's how we graph the derivative of a function.